All right, I'm going to talk a little bit about volume today and laying the framework for the stuff that we're doing in chapter 8. I always found that this stuff was really tricky, one of the trickier parts of calculus when I remember taking it. However, I found with the multivariate, or it's not the multivariate, with the BC kids, a lot of it's kind of hit or miss. Some students are really good at picturing this stuff. Their spatial awareness and spatial recognition is just on point, and for a lot of other students it's just really difficult to see. So it's going to take practice, and you may fall into either category, but I don't think this is one of the harder chapters overall. And I maybe shouldn't say this, but especially when you compare them to the chapters we're about to come into. So the basis for this is finding volumes, right? And we're most often going to be finding volumes when we're either rotating it around the x-axis or when we're rotating a shape around the y-axis, okay? And you sort of have to picture, if you're rotating it around the x-axis, your cross sections are going to be either discs or they're going to be washers, and they're going to be perpendicular to the x-axis. If you're rotating it around the y-axis, your cross sections are going to be either discs or they're going to be washers, and you're going to be perpendicular to the y-axis. Okay, so if this, let's just talk about this region right here between 0 and 4, and let's rotate it around the x-axis. What are my cross sections going to be? They're going to be discs. What's the radius of each disc going to be? The radius, now if you picture this height, this disc, this is radius is going to be the exact height of the function, okay? So you need to kind of use that to convert the integral from a to b of pi r squared dx, where r is going to be, r is some function of x, like that. What if I was to say, let's not rotate it around just the x-axis, let's rotate it around the line x is equal to -2. Then, okay, then what we have to think of is I'm going to have this other shape that's down here that's symmetric to it. And when I rotate it around, I'm going to have an inside circle and I'm going to have an outside circle, okay? And the cross sections are not going to be discs, they're going to be washers, okay? So if I have a washer, let's make it a little bit bigger. If I have a washer, how do I find the area of the washer? Well, a washer has a big radius and it has a little radius, and I'll use the little radius as the lowercase r and the big radius of capital R. So the area of a washer is r squared, big R squared minus r squared. Notice that it is not r minus r squared. Okay, so when you have a section with washers, you need to adjust your formula so that it's usually going to be the integral from a to b of pi times r, which is some function of x squared, minus little r, which is some function of x squared dx. Okay, how are you going to tell instinctively, like immediately? Well, if there's an axis of rotation and there's space between it, like there is in this case, see this space in between this, there's this shape, right? And I'm rotating it around this axis, and these little dashed lines represent space in between the area that I'm rotating and the axis that I'm rotating it around. I'm going to get a washer. That's what this space in the hole inside the washer is. So you need to use the washers when you have that, and you need to use the discs when you have that. Now, what's going to happen today is, so far we've been rotating them around a horizontal axis. However, it's possible to rotate them around a vertical axis too. And what you want to know is that what you want, so this function right here is y is equal to square root of x. But keep in mind that it could also be, I could rewrite this as x is equal to y squared. Okay, so in one case, y is the dependent variable. In the other case, x is the dependent variable. Most of the time, you want your function to be expressed where if it's horizontal, it's going to be y as a function of x. If I change this, and if I say I'm going to rotate it around the y-axis, then I'm going to want to change my function so that x is a function of y. And you're going to have to just play around with that. But let's just think of this. This is not a volume question. This is an area question. Let's say I want this area, but I want to find two different ways to find that area. Well, hopefully you can look at that and you can say, well, that's the area as x goes from 0 to 4 of the square root of x dx, right? That's taking vertical lines. X is like my Range Rover, and it goes from 0 to 4, and every time it goes from 0 to 4, it takes an infinitesimally thin slice, and that's how I get it. However, is there another way to look at it? I bet there's another way to look at it. What if I wanted to go with vertical slices all along this way? Shouldn't that give me the same area? It should. What would that formula be? Well, now my y, it's not my x that's varying, it's my y is going from 0 to 2. When x is 0, how big is that slice? So the slice is 4. And then it's 4 minus the square root. Nope, not 4 minus the square root. It's 4 minus y squared dy, not dx, dy. So those should be the same areas looking at it from two different perspectives. Let's see. Let's use Desmos to confirm. And let's go. This is the integral from 0 to 2. You notice that they're the same. So most of the times you won't have the choice. You're going to have to just notice that if it's rotating around a horizontal axis, you want to leave it in terms of x. If it's rotating around a vertical axis, you want to leave it in terms of y. If there's no space in between the shape and the axis of rotation, you're going to have disks. If there's space, you're going to have washers. There is one other scenario that we will at some point cover, and it's if, let's say you have a shape like this and we're rotating it around the y-axis, and if I look at my cross sections, it actually cuts in and out of the function or crosses the function 2 times. That's a different, and it's probably a situation that you won't have on the AP test, but I'm going to teach you the method that you can use for that, but not until the next video. All right, hope this was helpful.